Good afternoon, Amina. Let's wait for one more person. Mercy is here, I think. Good afternoon, everyone.
Good afternoon, teacher.
Okay. So last time we introduced resultant force, and we saw how forces can be reduced to one single force. When one, they are parallel to each other. Two, when they are facing the same direction. Three, when they are perpendicular to each other. Now, what if the forces that can be displayed are acting at different angles to each other? How can we go about it? This is what we are going to discuss this afternoon, which is under resolving of forces, or resolution of forces. But basically, this is seen or done when forces are basically acting at an angle. Okay. Two non-perpendicular forces. Two non-perpendicular forces. This is still under what we call resolution of forces. There are two methods. Of how to find the resultant of two forces acting at an angle to each other or about a body. I.e., one, there is the parallelogram law. There is the parallelogram law. Then two, is what we call resolving horizontal and vertical components. Whereby, for example, if I have a body like this one, and this body has two forces acting on it. One force P, there's another force Q. But these two forces have an angle theta between them. Then, when using method one, we sketch an appropriate vector triangle of forces. How? By starting with n of the forces, I can start with P, then I follow it with the Q, the way Q is placed, whereby this is the tail of P, this is the head of P. So I sketch the tail of P, and then at its head, I attach the tail of P, of Q, so that the head of Q lies here. But because of connection, we need to connect this tail to the last head of Q. And with this will become our resultant R. But we have seen that this angle was theta according to this angle between the two. So the angle inside can be realized as 180 minus theta. Now, why we call it the parallelogram law? It is because in the first case, I've started with the P, but someone can start with the Q. When I start with the Q, it looks like this, and then like that. With these arrows maintaining the directions they were in. With these arrows maintaining the directions they were in. So it means also this angle still will be the same. Because if you look at this one is theta, this one will be 180 minus theta. So this forms a parallelogram. That is how the principle of the parallelogram law comes about. Then if you recall, there is what we call the cosine rule. Amina, are you studying sub-math?
No, teacher.
No, why? You don't have, is it not on the timetable?
Yes,
It is there or it's not there?
it's there.
Why don't you study? Because now there is some knowledge in mathematics which they need to teach you in sub-math, which we need to borrow. Okay, but this one also you've ever seen it in O level. So if my R is what I'm looking for, the resultant force, it will be R squared is equal to P squared plus Q squared minus 2PQ cosine of 180 minus theta. With this, you can get R. Then the other bit also is resolving method 2. Oh, before that, you're also supposed to get the angle alpha, which that resultant subtends. Here we can use the sine rule, which says A over sine capital A is equal to B over sine capital B is equal to small c over sine capital C. Where is it coming from? Since no one is asking, let me answer myself. If you have a triangle with this A, this B, this C, the opposite side of angle capital A is small distance A. The opposite side of angle capital B is small distance small b. The opposite angle of angle capital C is small distance small c. So if you bring in that dimension, you'll see that alpha is opposite to Q. So Q over sine alpha is equal to R over sine 180 minus theta is equal to P out of over, there's an angle up here, we can call it what? Beta, out of sine of beta. You can use that relationship to find the direction. because we always have to find the direction as well. Now, method 2 is what I wanted to show you. Method 2.
Teacher, please pardon explanation for this angle, this sine A,
Sine rule, eh?
B, sine C.
Or sine rule, eh? This one, eh? Yeah? If you have a triangle, even this one I first used came from the same triangle. If you have a triangle ABC, and the vertices have angles capital A, capital B, capital C, the side opposite to capital A has a distance small a, the side opposite to capital B has a distance small b, the side opposite to capital C has a distance small c. So the ratio of the distances out of the sine of the corresponding angles of which they are opposite to each other is equal to the ratio of another distance out of sine of that same angle, which is opposite to that distance, is equal to the distance, for example, of C out of sine of the angle opposite to the side of distance C. And with that, when you look at our triangle from the parallelogram law, if it was A, B, C as our triangle, then the angle 180 minus theta is opposite to R. So I say R over 180 minus theta. The angle alpha is opposite to Q. So I say Q over sine alpha. The angle opposite to beta, the angle opposite to P is beta. So I say P over sine beta. So with that, we end up having the ratio using the sine rule. For method 2, method 2 calls for this. That since you see the body is like this, and the body has P, and the body has an angle with which two Q subtends. When you resolve the force P, Q to the horizontal, you need to also resolve it to the vertical. So if I extract out Q alone, it looks like this. Now I'll need to get the horizontal, which is the adjacent. The vertical is going to be the opposite. Where Q is the hypotenuse. Now, adjacent over hypotenuse is equal to the cosine of the angle. So adjacent will be equal to hypotenuse cos of the angle. Therefore, on the horizontal here, you have the hypotenuse, which is Q cos of theta. So in the horizontal, you have Q cos of theta. Opposite over hypotenuse is equal to sine of theta. Therefore, the opposite will be equal to hypotenuse sine of theta. So this is hypotenuse, which is Q sine of theta. So this will be Q sine of theta. So what does this mean? It means as you see Q compressing the angle, you use cos. When you see Q moving away from the angle, we use sine. You can cram forever. But whenever we compress an angle, we use cos. Then whenever we move away from the angle, we use sine. So therefore, in this horizontal direction, it is the same as someone saying, we have this. In the horizontal, we have P plus Q cos theta. Then one also to say in the vertical, we have Q sine of theta. Then after you use Pythagoras theorem to get the resultant. So the resultant force R would be R is equal to square root of Q sine theta squared plus P plus Q cos theta squared. Then you can get the answer. Of course, here it doesn't look so good. It's going to look better when we have an example. unless if people have questions on the definitions. Otherwise, I'm ready to give an example. There is also a screenshot I want you to have. Mathematicians have sent you a book called Bostock, Advanced Mechanics and Probability. But just for Amina, who is not a mathematician, let me also share this screen. You take a screenshot, you will do some more reading because the physics needs the notes. So have this screenshot covered, because it is trying to explain what I've been trying to illustrate before. Just take a picture, read more about them. Are we there? Also take this one. So as you take this one, I'm going to look at this very example. I'll need you to just tell me what the answers are and what the dimensions are. Find the resultant of two vectors of forces, 8 newtons, 10 newtons, if the angle between them is 60. Okay, so I want to do this number. I want to go back to the white page. Can I go back?
Yes.
Okay. So going back to the white page, the question says we have a component of 6 newtons. We have another component of 8 newtons. The angle between them is 60 degrees. So method 1, we are going to use or to borrow the parallelogram law. If I borrow the parallelogram law, I'm going to have the following. I will have this. I sketch the 8 first, for example. Then I follow it with the 6. When I follow it with the 6, remember we have seen this is what? 60. So the angle inside is going to be what? I mean, what angle is going to be inside?
120.
Very good. We have 100 what? 20. So this is the resultant. We shall also need to get its angle. We don't know it. Remember, I told you if you want to confirm that what you've done is right, you can investigate the parallelogram law by saying, what if I started with the 6 newtons? And then I followed it with the 8. Is the resultant the same? If yes, then you're on the right track. And this would be your 6 newtons. This would be your 8 newtons. Therefore, to get the resultant R, I will use the cosine rule, where R squared is going to be equal to 8 squared plus 6 squared minus 2 times 8 times 6 cosine of 120. From the definition of A squared is B squared plus C squared minus 2BC cosine of theta, or cosine of A. So R1 will be the square root of what? 64 plus 36 minus 48 times 2 is 96. Cos of 120 is negative a half. Not so. So negative a half, I'll get 96 times negative a half, which will give me square root of 100 plus 48. So the answer becomes root of 148. Which answer is that one? That is 12 points. This is 12 point what?
12.1655.
1655, okay, 167. Physics, 2 decimal places are enough. Now we need also to get its direction. The direction is going to be 6 out of sine of alpha is going to be equal to r out of sine of 120. You can use any two, though they were 3 in the definition, but any sides is okay, any 2 sides. So I can make alpha the subject by saying 6 out of root of 148 is equal to times sine of 120 is equal to sine of alpha. This one has gone up, also this one has gone up. So can we get alpha? Alpha is equal to
The higher 25.28.
pardon?
25.28.
25.28 degrees above the 8 Newton force. This is the best conclusion because you don't need to put a compass to say east 25.28 degrees north. You don't need to use bearing to say north 90 minus 25.28 degrees. So it's better if you have not given you those items, you conclude using that. Okay, I want to go to method 2. That was our method 1. I told you when figures come, it will look easier. We have the 6 newtons. We have the 8 newtons at an angle of 60 degrees. Therefore, if I resolve the 6, I will have 6 cos 60 because I'm compressing the angle when I'm moving down. When I go to the vertical, I will have 6 sine 60. Therefore, sum of forces in the horizontal will be 8 newtons plus negative 6 cos 60. This reduces to 8 minus 6 cos 60. And this will give me 8 minus 3. And the answer is 5 newtons positive. When we get a positive 5, the sum of forces in the vertical are 6 sine of 60 because we resolved, which will be 6 times root 3 over 2. When you press a calculator, it is 0.866. When you divide by this, you end up having 3 root of 3. Now, we have a horizontal component and a vertical component. Remember, the resultant of horizontal and the vertical components, we use Pythagoras theorem. So the reason why we resolve is to make sure that we reduce them to vertical and horizontal components so that we can introduce Pythagoras theorem. Therefore, the resultant force will be sum of forces in X squared plus sum of forces in Y squared. And with this, the resultant force will become what? Square root of 5 squared plus 3 root 3 squared. Hey, wait, I made a mistake. This was not minus, it was plus, so it's a positive. So if it's a positive, it makes this 11. I was already seeing the answer was different. I was wondering. So this is what? 11. If it was facing the west, it would be a negative. Eh? So R becomes what? Square root of 121 plus 9 times 3, 27. You see that the answer is the same as square root of 148, which is the same as 12.17 Newton. Then, the direction, tan alpha is sum of forces in Y out of sum of forces in X, which is going to be 3 root 3 divided by 11. Can you get me alpha? So this alpha was, okay, this was correct. Alpha is going to be equal to tan inverse of 3 root 3 out of 11. Calculate, what answer do we get?
25.28.
25.28 degrees above the 8 Newton force. So we get the same answers. Eh? So you can have that screenshot. You need an example in that category. Are we there? Okay. I was asking whether people are, I should give them another example of that category or. So I'll also share, you can also visit that book and have some of those examples catered for or tried out, which is post-talk. Now, if I can proceed to another kind of example, allow me first bring out this definition. What if the forces are more than 2 acting on a body? There are 5 forces. How can we get their resultant force? You have a body, it has a horizontal force P, it has a force Q acting at an angle theta. You have another force R acting at an angle alpha. Perhaps you have another force T acting at an angle beta to the vertical. So the first things you do is to identify the horizontal and the vertical lines. This is case 2. This is the vertical line. This one is always the horizontal what? So first identify the vertical and horizontal lines. When you do that, resolve. The forces which are horizontal, don't bother them. The forces which are vertical also don't bother them. Just move the others to the vertical and to the horizontal. For example, let me ask Amina, if I want to move the force Q to the horizontal, what will it become as I compress the angle theta?
Cos theta.
It will be?
Cos theta.
Q cos theta, not so?
Yes.
So I'll have Q cos theta resolved. Still on you, Amina, if I move Q to the vertical, what will it become?
It becomes Q sine theta.
Very good.
Q sine theta.
Thank you so much. So Q, you don't deal with this one anymore, but you deal with the resolutions. That's why it's called resolving. I have another student in class. Cynthia Ainembabazi, can you move for me T to the vertical? Cynthia Ainembabazi, move T to the vertical.
T sine.
Yeah?
T cos B.
T cos beta. This is red beta with a long stick. Then if I move T to the horizontal, what shall it become? Cynthia, still with you.
T sine B.
T sine
Beta.
beta. Thank you. Can I have Nelda Esther? Can you move for me R to the vertical first? Nelda Esther?
R cos
Are you
alpha. R cos alpha.
Where are you moving it?
To the vertical. Sorry, to the horizontal.
Yeah, okay, very good. That is lovely. I wanted to know that you know what you're doing. So for Hasha's first move to the horizontal, which is R cos alpha. Can you move it to the vertical, Esther?
It will be R cos beta.
You have already given me that one. You are moving away from the angle. We said when you're moving away from the angle, we use Esther, what do we use when we move away from the angle?
We use alpha.
Trig ratio. Do we use sine or cos? Look here. We compressed theta here. We got 2 cos. We moved away, we got 2 sine. We compressed beta here, we got t cos beta. We moved away, we got t sine beta. So whenever we move away, what do we use?
We use sine.
Now, can you tell me, are we moving away from the angle or we are compressing it?
We are moving away from the angle.
So give me the ratio which has been resolved.
The angle will be
the force
R
now.
sine.
The force is R sine.
The force R sine beta. Sorry, alpha.
Okay. Now, members,
Yes.
listen to me very well here. The forces now you see in red, plus this force I did not resolve, are the forces we consider. And we can say horizontally, some of the forces in the horizontal, pardon? Some of the forces in the horizontal is going to be, first of all, we have P, plus those forces facing where P is facing, plus 2 cos of theta. Then overcome the opposite force going to the west because of the rule which says when forces face opposite directions, we subtract. So we subtract off R cos alpha. Then in the vertical, sum of forces in the vertical, upwards we have 2 sine theta minus the downward forces R sine alpha plus T cos beta. Still, if you want to get the resultant force, you will get the square root of the sum of forces in the horizontal squared plus the sum of forces in the vertical squared. So we can have that definition down, unless someone has a question. But I know we can best understand it when we bring out its what? Its examples. So, can we go for an example? I hope people have taken the screenshots. There is an example here, guys, that I want to look at. Let me first screen share this. Take that screenshot. I need this number. This one. I need that number. Let's have it. Have you taken a screenshot? I want to go back to the other page. Let me just screenshot it with the camera here so that I can have it clear. If you go back to the main screen, shall have the following. There is an estimated horizontal line. We have a horizontal here. Then we have a vertical component here. Then we have another angle here. Then we have another one this way. But this is 2 newtons. Then this is 4 newtons. This is 3 newtons at an angle of 60. Because this is vertical, the angle is 90. Then this one has an angle of 30 degrees. Okay, here is our question. The question says, find the resultant force. Oh, but this is 1 Newton. Find the resultant of the forces. One, we shall need to resolve. My friend here who never mentioned anything last time was Mercy. Mercy, where are you? Mercy, give me the resolution of 4 to the horizontal.
4 sine 60.
Eh?
No, 4 cos 60. 4 cos 60.
4 cos 60, very good. Mercy, give me the resolution of 4 to the vertical.
4 sine 60.
Mercy, also give me the resolution of 2 to the vertical.
It's 2 sine 30.
Give me its resolution to the horizontal.
2 cos 30.
Very good. Now, there are various ways. One can even use a table. I forgot to show you that. One can say, me, I want a table, simplicity. Sum of forces, this is forces in X, forces in Y. Or one can say horizontal and vertical. Then the forces are 1, 3, 4, and 2. One in the horizontal, it is 0. In the vertical, it is 1 because it is acting only in the vertical. For 3, horizontal is 3. In the vertical is 0 because it is purely acting in the horizontal. 4 is having 4 cos 60 and 4 sine 60. 2 is going in the east, west, negative 2 cos 30, 2 sine 30. Down here, I'll have sum of forces in X, sum of forces in Y. It is from here that you end up seeing this expression and this one by summing up. When someone says sum of forces in X, it will be 0 plus 3 plus 4 cos 60 minus 2 cos 30. Realizing 3 plus 4 times a half minus 2 root 3 over 2. which is 5 minus root of 3. When you come to the vertical, sum of forces in the vertical is the same as 1 plus 0 plus 4 sine of 60 plus 2 sine of 30. The advantage of the table, you don't have the challenge of knowing, hey, wait, this one was going down also. The down is a negative vertical. So this is a minus. Calculator. Divide. You realize root 3 minus 1. Give me this answer. Give me this answer. As you take a screenshot, calculator. Ah, is it raining also on your side? I don't know if I can hear the rain behind me. What answers have you got? Sum of forces in the horizontal, what did you get? I remember the vertical was 2 root 3. Sorry, 3 root 3 minus 1. Then this one was what? What was the horizontal? Someone tell me that answer, please. Network disturbing you. I mean, yeah, what was the sum in the horizontal? All people never took screenshots.
Five minus add 3.
5 minus, like that. Eh? So what answer do you get here? And there.
It's 3.26.
Then this one.
4.24.
Therefore, if both of them are positives, then you sketch the sum of forces in the vertical, the horizontal, followed by a positive sum of forces in the vertical. The resultant acts along this line. Therefore, the resultant R will be the square root of sum of the forces in X squared plus the sum of forces in Y squared, which will give us the square root of 3.26 squared plus 4.24 squared. What answer do you get?
$5.34.
So we also get the direction. Sum of forces in Y out of sum of forces in X. So theta is tan inverse of 4.24. What answer do you get?
$52.4.
2.4 degrees. So with that, you have found the resultant of the forces, which were many, by first resolving them to the horizontal, and then also resolve them to the vertical. So I'm going to send the book Bostock. Go to page 39. But why don't I give you the numbers? They're directly here. Take the screenshot of these two numbers here on exercise 2H. This one and this one, they are the numbers you're going to do. Find the resultant of those two forces. Of those systems of forces. Have you taken the screenshot?
Yes.
So there's something I want to conclude with the other parts. Now on this number, they can ask you for the acceleration. If the forces act on a body of mass 5 kgs, find its acceleration. Remember, resultant force is defined by mass times acceleration. So you have got a resultant force of 5.2, 5.34. You have a mass of 5. You are looking for the acceleration A, divided by 5, divided by 5. You realize that the acceleration is 5.34 divided by 5. You'll find some of these questions asking you such, which will give you 1.68 meters per second squared. When you confirm with the calc, is that the answer?
It's 1.068.
1.068. So therefore, one should know that whenever resultant force is mass times acceleration, you can deduce acceleration from the resultant force out of the mass. Then you can have the answer. Okay. Any questions before I can close?
Teacher, in the previous number, how are we calculating for sine of 90 and cos of 90?
Okay, very good.
Angle.
Thank you. Like for the other force which has 1, like 1 was vertical, not so. Is that
Yes.
what you're asking? Yeah?
Yes.
Now look here. If I move this way to the horizontal, I'll be compressing what angle?
90.
Give me the resolution to the horizontal.
1 cos 90.
1 cos 90. Is that okay? To the vertical, this is the line of the vertical, not so. I am exactly here. What angle would I have gone through? What angle would I have gone through if I'm exactly where I am?
180 degrees.
You are exactly where you are. Have you moved any angle? You are on this line. You are in the vertical line. You are not changing any direction, not so. You are exactly along the same angle. So what angle have you moved?
0 degrees.
Very good. I was about to wonder, don't I have some trick students here? So this would become 1 cos of 0 degrees. But do you know that 1 cos of 0 is 1? In the
Yes,
vertical.
teacher.
Whereas cos of 90 is?
0.
That is why in the horizontal, I say there is no component of the 1 because 1 is purely acting vertical. The same applies to the other force, which was here. What was it?
3 newtons.
I think now you understand why 3 was taken only in the horizontal. In the vertical, it does not exist it. Otherwise, if this is in the vertical and you compress the 3 to the vertical, you'll get 3 cos of what? 90, which gives you what? 0. That is why 3 only acts purely in the horizontal and 1 acts purely in the vertical. Have I explained that very well? To your satisfaction? Yes?
Yes.
Okay. Girls, any other question? When you visit those mathematics books for physics, don't solve very many. You solve just a few, 1 to 10 numbers. For mathematics, in the mathematics books, you solve all the exercises plus the examples. Because math is all about solving all or solving very many numbers. Physics is all about getting to know the concepts. All right? So if no further questions, I think we can stop here. Okay, have a wonderful afternoon.